I don't remember trying this tea before. No. No. What? You go, girl. I bet she does. All righty. The first two are, of course, the important ones, because that's the next thing you're going to be taught or checked for. 2x squared minus 4x plus 4x minus 8. Then we collect our like terms. 2x squared, negative 4 plus 4 is gone, minus 8. Easy peasy, lemon squeezy. Factor that. Step 1, decide on the GCF. What is it? It is 18 and x. Why only one x? Because it's the lowest, the greatest amount of x's that everybody has. And a y. Then we write it out. GCF first, and then all the answers. What's the first one? xy squared minus 2 y squared plus 3z. And we are done. I do not know what this z is of which you speak, because I speak English. Of course you can't simplify that. This, as Jacqueline asked before she left, I need to multiply to negative 30 and add to 13. What is it? What is it? 10 and 3. Okay. Which one would be positive? Which one would be negative? Or were they both positive? Or are they both negative? They're both negative? They're both positive. They're both positive. Okay. One's positive, one's negative. But that doesn't add to 13, does it? So what is it really? It's 15 and 2. X plus 15, x minus 2. Got to remember, sometimes you got to go past the 12 times table. 15 minus 2 is 13. 15 times negative 2 is negative 30. And what's this guy? Multiply to 12, add to negative 7. What is it? Negative 4 und negative 3. And that's where we left you. I left you there. So I asked you to do the questions on page 132 is where I left you. You have not seen answers to 132. So this will take a moment. Please check your answers over. Make sure you have the right answers. What should you do if you have a different answer than me? Write it down and ask how it came about. Z plus 8, Z minus 5. Y plus 4, Y plus 5. Now, are you allowed to have Y plus 5 and Y plus 4? Of course you are. This one, we bring out a 2, and we get x squared minus 6x plus 4. And there we must stop, because there are no factors of 4 that add to 6. Here, this one often messes kids up because they don't notice that k squared and k squared, 18k squared minus 18k. Factor it, of course, you bring out 18k, and that leaves in k minus 1. Is that your way of asking me how to do that one, Mr. Myers?
Yeah.
Okay. You understand that 3k squared and 15k squared is 18k squared, yes? You understand that 18, 18, k, 18k is the greatest common factor. Then you would divide by the greatest common factor and put the answers in the middle. 18k squared divided by 18k is k. 18k divided by 18k is 1. This one is 6x cubed y, and that is 4x minus 3. Done. This one is x plus 9, x minus 9. Thanks, Brab. What's this one? Oh, okay. It's x squared plus 16 and x squared minus 16. Now, there are a few people in the room that already noticed that will go further. But if you didn't and you left it here, you're okay. After today's class, you will go further with that, and I will show you what I mean when we get into today's lesson. Okay? This one always messes kids up. I talked about it last day because they don't know what to do with that. The math that is happening right there is multiply, yes? Which means x and x minus 2 are factors, aren't they? Because x times x minus 2, so those are two factors. 3 and x minus 2 are a factor, aren't they? Which means x minus 2 is a factor in both of them, which means it is common to both of them, yes? When you have something that's common to everything, you can divide by x minus 2, because that's the common factor. Then you write the common factor there, and then you write the answers there. Now, there's another way I like to show this that actually makes life much easier later on, and I'm going to show that to you right now. What if I told you a equaled x minus 2? Now, what could you write here instead of this? You could write x times a, correct? Plus 3, and that's an a, isn't it? So 3a. Now, you can quite plainly see there's an a in both of them, isn't there? So if I divide out that a, I write the GCF first. Xa divided by a is x. 3a divided by a is 3. A times x plus 3. But a is x minus 2. So I rewrite it. Now I'm showing you this because it is a very handy trick that you can use later when the equations get really, really ugly. Okay? You can always do something like this. And this move will help you right here because that and that are the same. So let's say I'm going to make them m. You can make it any letter you want. 2am plus bm. M comes out, and that leaves 2a plus b. What's m? A minus b. And there's your answer. Now this one, somebody asked about on Thursday, and that's why I showed you. You're not sure what to do, but you can see that that and that are almost the same, aren't they? This 2x is positive, this 2x is negative. This 3 is negative, this 3 is positive. So if I divide that by negative 1, is that okay? It is, because 1 is a factor of everything, correct? I can always divide everything by 1. So that means I'm going to bring that negative 1 out here. What's already out here? A negative 5. What's negative 1 times negative 5? Positive 5. So I get x, 2x minus 3, plus 5 because of this, and then positive 3 divided by negative 1 becomes negative 3, right? And negative 2 divided by negative 1 becomes positive 2. And now we're at this case where they're both the same. And we know we can write 2x minus 3, and then what's outside the brackets, x plus 5. Yeah, yeah? Yeah, yeah, yeah. And then this was just multiplying, x plus 3, x plus 3. Remember, I always like to leave the first one alone. I don't like to touch that one yet. I do this one. Can I use the handy little shortcut here? Yes or no? Why? Just for this part, can I use the handy little shortcut? Why? But that's why I'm asking just for this part, Helia. Can I use it just for what's highlighted? Nathan? I know it's blue. Keep going. Yeah, you can do this, the shortcut right here, because it's x and x. So we know that it's going to be x squared plus 6x plus 9. Now, I got to distribute here. How many distributions must I do? I must do 3 distributions with x, and then 3 distributions with 3, for a total of 6 distributions, yes? What is the first line going to be? X cubed. 6x squared plus 9x. What will the second line be? Plus 3x squared, keeping the x squareds together. 18x, keeping the x's together, plus 27. And what is my last step always? Collect my like terms. X cubed plus 9x squared plus 27x plus 27. And this one is just FOIL. What will the first line be? No. 10x squared, 6xy. What will the second line be? Plus 20xy minus 12y squared. And then I collect. 10x squared plus 14xy minus 12y squared. Yeah? Everybody's good to go now, yes? Our brains are back to math? Spectacular. Turn the page over, if you would please, to page 133. Now, like I said, 133 is kind of a bridge between the two kinds of factoring that you're going to end up doing. And you've already done it. If I asked you to expand this, what would happen? You'd have to do FOIL, right? And what would you get? X squared minus 4x. Then what? Positive 4x (16). Now, if we were going to collect like terms, we would not write anything in the middle, would we? No. But for teaching purposes, I am going to write that in the middle. Because you have already seen that, haven't you? Right? When I was teaching you how to factor. You needed numbers that multiplied to 16 and added to 0, right? And you noticed that it was always the square root of that one, wasn't it? And it's happened here again. The square root of 16 is 4. 4 and 4. Right? So, if it's happened once in math, and this has happened more than once in our class, hasn't it? How often will it happen? Always. What do you notice is special about x squared minus 16? Please notice I'm going to highlight those three words. They are both perfect squares separated by what math, Sam? Subtraction. When you subtract, you find a difference, yes? So if you have a perfect square and you are subtracting another perfect square, you have a difference of squares. And the answer is always this. I'm going to call that capital A, capital B. It is always the square root of A plus the square root of B. And then you write it again. The square root of A minus the square root of B. And that always works. Now, let's go back and just prove it to you to make sure that everybody believes me, because, that's what I like to do. I like to make sure, for example, right here. Here, this is a better one. If this wasn't there, that's what it should be, right? Square root of x squared is x and x. Square root of 81 is 9. 9 and 9, plus minus. Everybody got it? Now, somebody always asks me at this point, well, Mr. Myers, what if it's x squared plus 16? That does not work, does it? Because if I take the square root of that, it's x. And the square root of that is 4, right? For it to be plus, this would have to be plus 4, wouldn't it? Or it would have to be minus 4, wouldn't it? But when I FOIL that out, I end up with 4x plus 4x. There's a middle term, isn't there? And if I FOIL this out, I end up with minus 4x, and I get a middle term. It only works if it's a difference. Does everybody understand? Now, what is it about an exponent that tells you if it's got a perfect square or not? Nathan. It has to be even because it has to be cut in half, right? So, let's look at our very first question here. Is that, and I'm going to label him A, is A a perfect square? How do you know? Because 16 is an even number. So if I need a perfect square, I need two exactly the same, yes? What is the square root of x to the 16th? X to the 4th? Okay, so that would mean that x to the 4th squared would equal x to the 16th. Does it? That is x to the 8th. So what must I need here to make 16? I need x to the 8th. Because when I multiply, I'm going to add 8 and 8, yes? So what do I need to remember? Not only do I remember that it's even, but the square root of x to an even number is x to that number divided by 2. Everybody cool? Okay, so it's x, 8, and 8. And then this is b. So I've got the square root of a. It's x to the 8th and x to the 8th. What's the square root of b? 1. So it's plus 1 minus 1. Now, I have done one step. Yes? Okay, now look. Is that an even number? So is that a perfect square? Yeah. Is that subtraction? Is 1 a perfect square? It's not. 1 times 1? Is that a perfect square? So, this is another difference of squares, isn't it? Is this guy done? Yeah. So that guy's going to stay the same. He's going to be x to the 8th plus 1. But this guy's got to break down into what? X to the 4th plus 1 and x to the 4th minus 1. Surely I'm done now, yes? Don't call me Shirley. Get it? Surely I'm done now. Don't call me Shirley. So, x to the 8th plus 1. X to the 4th plus 1. Now what happens? Plus 1 and? Surely I'm done now. No, of course not. Why? Because I can do it again. How often do I have to do this? Until I am done. It is tedious. And lastly, now I am done. Now, as Satjo just said, well, couldn't you do that from the beginning? If you're good enough with math, you can. When I look at this, I see this. Most of you probably don't yet. Everybody cool? All right. Let's have a look at number 2, because number 2 looks different, doesn't it? If number 2 was this, what would you do? So what would it be? X 25? What's the square root of 225? I did say memorize them, but it's 15. And then what would this be? Minus 15, correct? Okay. What if there was no x there? What would it be? It would be y and y. So when they're both there, what is it? That. Everybody understand? Everybody said they understood this, which means you automatically understand this, even though it looks different. Okay? Let's look at number 3. What's weird about number 3? There's 8. Is that a perfect square? Sure it is. How do I make it a square root? So it's z to the plus 12, and then and I'm done, right? Why not? I can do that again? Really? 12 has a square root? So am I done? Yes. It looks like I can carry on, but I cannot. It is just as important to know when you have to stop as it is to know when you have to start. Right? Now, 4 requires you to put a lot of stuff together. You need to think real closely. Remember, you know what to do if it's that, right? What would you do if it was that? You take the square root of the first one, and you take the square root of the second one, right? Which we've done 3 times, haven't we? So, do that here. What is the square root of that? 2x cubed. Plus, what is the square root of that? 5y. And then what do I do? Same thing, except it's minus 5y. And now you can't do anything anymore. Now, ladies and gentlemen, that's all there is to it. Except, why have I left that much white space if that's all there is to it? There's weird things I can do to the question. Does that change what you do? No. For example, what if I gave you this? What would you do, Sajid? You would divide by 3? Only 3? What's the first thing? 3x. The first thing you do is always GCF, correct? Now, I got 3x outside, and what have I got inside? minus 4. Am I done? Now I get x plus 2, x minus 2. That's the first mistake you guys are going to make. You're going to forget that very first thing I taught you to do that I said you're supposed to do every single time, right? Well, that's greatest common factor factoring. That's the first mistake you're going to make. Here's the second mistake you're going to make. What if I gave you this? No, wait, I don't want to do 16. We'll use 9. What if I gave you that? What do you notice here that's making you think that you have something to do? You see that that is squared, yes? What's that? Minus? What's that? And 9 is a perfect square, isn't it? So isn't that a difference of squares? But when it was this, x squared minus 9, it was easy. What was it? X plus 3, x minus 3, right? Well, what's different here? It's that. That's the base, right? Well, when it was x squared minus 9, it became x and x, yeah? I just put this base. So what do you think I'm going to put here? X plus 4. X plus 4 plus what? No. Okay. See, that's what I mean. I told you what you could do with this. This is ugly, right? What are you allowed to do? You're allowed to make it pretty. What if I told you A equaled x plus 4? How would you rewrite this? A squared minus 9, right? Which would become what? But there is no A, is there? What's A? So isn't this really x plus 4 plus 3? Which is what? X plus 7. No tricks here. And what would this really be? X plus 4 minus 3, which is x plus 1. And now that one's done. Everybody see? Okay. What? No, that's something you would do. That's the hint I'm giving you. Now, would you be allowed, do you think? Would you be allowed, do you think, to do this? And expand that out. Do you think you're allowed to do that? Can I do x plus 4 times x plus 4 minus 9? Sure I can. That would get me x squared plus 8x plus 16 minus 9, correct? And what is 16 minus 9? 7. And that factors, numbers that multiply to 7 and add to 8, are x plus 7 and x plus 1. Did I get the same answer? Which way was faster? Second one's easier for you, Nathan, so which way do I expect to see you doing this work? Second one. Will I take away points from you? Does it show me you know what you're doing? Great. How many of you find you are short on time? How do you save time? By doing less work. Do I care? No. Could I have done both of these just as fast? Yeah. How did I get there? Practice. Same way you get everywhere. Everybody good? Okay, now, the hardest one you can get is this. Barf-tastic. That's really hard. Yep. That's what you would do. You'd say that's A, that's B. What's the square root of A squared? A plus, what's plus B, and then A minus B. And what's A? X plus 2 plus X minus 6. Then you'd add them. Then X plus 2 minus X minus 6. Then you collect your like terms. Everybody cool? Of course I can. What is A? X plus 2, right? So A is X plus 2 plus what's B? What is X plus X? No. 2X. What is 2 plus negative 6? Negative 4. That's the first half. Then I got to do A minus B, which is X plus 2 minus X minus 6. What's X minus X? X minus X. 0. What is 2 minus minus 6? 8. 8. And that is almost completely done. There's one more thing you would do there to the red one. What would you do? You can simplify it how? You would take out a 2. Right? And when that 2 comes out, there's already an 8 out there, so what will it become? 16 x minus 2. And that is that factored. That's really, really hard. Okay? I'm going to maybe show you one like that on a test, right? But that's just to make sure you can do it. Nathan. If you multiplied that 8 in there, you are not factoring, you are expanding. You want the simplest things possible, right? Okay, now, listen up. 134 and 135 is what we are going to do today. But I want to talk about 136. So here's what I'm going to do. Class goes till 2:20-ish. I want at 2:10 to be going over 134 and 135. All right? So work efficiently, because I want to be talking about 136 before the end of the block. Okay? Everybody good? Let me remind you, you have 3 tools at your disposal. 1, you have GCF. If you don't remember how to do that, you need to look back. It's on page... Oh, I lie. Worst kind of liar. Stop it, Mr. Myers. You're such a liar. It's hurtful. Ah, there we go. It's on page 127. GCF is on page 127. The second thing you have is this one. And to factor that, you need numbers that add to B and multiply to C. And that you will find on page... right there, 129. And the third thing you have is difference of squares. X squared minus y squared. As long as this is a square. Then you take the square root of the first one, square root of A plus square root of B, and then you write it again with a minus sign. And that is the page we are working on right now, which is page 133. You may have to use a combination of them, okay? As I showed you on this question, right? You may have to use a combination, but it's all available to you. Start on 134 and 135, do the best you can. What should you do if you get absolutely stuck? Ask or skip. If you leave 6 blanks, they're all the same type, then it's real easy for you to know what you got to pay attention to tonight, right? Okay, go. Is that subtraction? Is that a perfect square? So what do I do with the first one? I take the square root. What's the square root of x squared? X. Then I take the square root of the second one. What's the square root of 49? 7. And then I write it again with a minus sign. Mr. Myers, did I do it right? Did I do it right? I don't know, kid, did you? Is x times x x squared? Is x times negative 7 negative 7x? Is 7 times x positive 7x? That makes 0. Is 7 times negative 7 negative 49? So I did it right. This one, is that a perfect square? Yes, it is. Is that a perfect square? Yes, it is. Are they being subtracted? Yes, they are. So I take the square root of the first one. What is the square root of 9x squared? 3x. Plus, what is the square root of the second one? 5y. And then I write it again, except there's a minus between them. Is this a perfect square? No, why? 2 has no square root. So I don't like that too. I better get rid of it. What's the only way to get rid of something? Divide by 2. Can I divide that guy by 2? Yeah. Sure I can. So I get 2x squared minus what? 25. Is that a perfect square? Yeah. What's the square root of x squared? X. Is that a perfect square? What's the square root of 25? Plus 5. And then I write it again with a minus 5. Is that a perfect square? Is that a perfect square? How do you know? Because the exponent is even. So what's the square root of that? X squared. Plus, what's the square root of that? 1. Then I write it again with a minus sign. Am I done? Of course not. Why? Because I can do it one more time. X plus 1, x minus 1. Now this one isn't the difference of squares. This is one of the second types, right? I got to multiply to what? And add to what? Negative 17. If that's negative, but that's positive, then I must need 2 negative numbers, yes? Okay. So what is it? It's 12 and 5, right? X minus 12. X minus 5. Most kids do 20 and 3 there. Yeah, that works. And this one, is that a perfect square? What is it? A. Is that a perfect square? What is it? And then I write the same thing, A minus 11. Yeah? Yeah. Carry on, my wayward sons and daughters. There'll be peace when you are young and meet an otter. Well, the song is Carry On, My Wayward Son. There'll be peace when you are young. But this is not a unisex class, so I have to say Carry On, My Wayward Sons and Daughters. There'll be peace when you are young, because son and young is how the original song went. But then I needed to rhyme something with daughters. And the only thing I could think of was otters. So there will be peace when you are young and meet some otters. Lay your weary heads to rest. Don't you cry no more. See, that works because you all have heads that you can lay down. At least, I think so. You all physically have the thing on top of your neck. But it isn't. Yes, it is very difficult to use Lego to build the Manhattan skyline. But it's not difficult to use Lego. You just click the pieces together. It's the exact same thing. You do have an instruction manual. Your notes tell you every step to do. You were away. You know, that sucks when you're away. If only your teacher cared enough to have a repository of all the notes that he does. If only you had a teacher that cared so much about your academic well-being, Tushar, that he was willing to record his lectures and put them out for everyone to see. Three more minutes, then I'm going to go over 7, 8, and 9. Jenna, are they always like that? Okay. I don't often hear it. They're kind of mean to each other. These two. You're the dumb one. No, you're the dumb one. Use your calculator. You're a calculator. He's the troublemaker?
Yeah, I'm actually nice.
I see. One more minute. Then I will go over 7, 8, and 9. Well, actually, in one more minute, I will ask if any of you are confident enough to take the magic pen and do 7, 8, and 9. I will bring the computer to you.
Can I do 7 and 9? Can I do 7 and 9?
Wait, what?
Hey, David. What? Well, that's the beginning of right. Isn't x squared a perfect square?
Yeah.
Well, then go fix it.
You know, 3 doesn't have a square, so you can't do it anymore, right?
Nope.
So that's done.
Is it?
Yeah,
Okay.
I think so.
Mr. Ellis.
The only reason I got that one wrong because I forgot to square root the 25.
I know you did.
I figured that out eventually. I think, couldn't you just square root the 1 over 9? Am I...
Of course.
Or it would just be 1 over 3.
Of course. Because 1 over 3 times 1 over 3 is 1 over 9.
Perfect.
All right. Who's taking the pen? Come and grab it. Okay, everybody. My good friend Rylan. Cheer him on. Here we go. Oh, wait. Take the chair, Rylan. By all means. Have a seat. It might be a little warm because my butt was on it. I know how gross that is, but you're cool. Ready?
We're gonna do
Go.
it.
What are you doing, Rylan? Why are you doing that with the 3?
Oh, because that's what I did.
But why? Be strong, Rylan. So close. There's one missing thing. What is missing? Crap. You gotta leave that 3 at the beginning.
Oh.
Because you have to be, ladies and gentlemen, You have to be able to get from here back to here. So x times x got me x squared, 4 times 4 got me negative 16, and then 3 times x gets me that, and 3 times 16 gets me that. Who would like to do number 8? Isabel. I like that. I know. Everybody makes fun of me. Booyah, Grandma! Is she right?
Yeah.
Can you get back to the original? Yeah. So she's right. Who's going to do number 9? Oh, you're going to try it again? You going to do it right this time? Okay, go for it.
Do we get a gummy bears for this?
This is Ryland's big chance to redeem himself. No pressure, Ryland. No pressure. We'll make it like a driving test. Boom, 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 boom.
Oh, I did the wrong bracket.
Yeah, go.
How do I erase?
You turn it over and you erase, man. It's the 21st century.
Oh. That's cool.
What? No? No. Is he right? Yeah, he's right. You did that part for him? What do you need, Nathan? We are going to do more. Why does number 10 freak you out? Because it's a fraction. What if I wrote 9 minus x squared? Is that a square?
Yeah.
Is that a square? So you take the square root of that and square root of that, right? So isn't that a perfect square? What times what? 1/3 plus x, 1/3 minus x. Oh, this one's not perfect square. What do I got to do? I got to multiply to what? And add to what? -4. What is it? 1 and -5. X plus 1. X minus 5. What about this one? I got to add to what? And multiply to what? Does anything do it? 3 and 3. X plus 3. X plus 3. Nicely done. And lastly, anybody want to come and write it down? Come on, Nathan. That's okay. Huh? I know Nathan's messy. Writing is messy. I mark Nathan's work.
Well, how do you do that? I don't even know. I can't even read it half the time.
I know that. Nathan, I mark your work.
Whoa, that's pretty cool. He just guesses what I write. That's right. I just get lucky a lot of the time. Yeah. Now I'm completely forgetting. Yee, David. I give up. I don't want to do it. I give up. I can't draw.
No, keep them there.
No.
Is he right?
Yeah, so far.
Damn right he's right. Now what?
4.
Plus 4 and? Same thing but minus 4. Is he done? No. And then?
X squared plus 2. X squared minus 2.
Is he done?
No.
Is he done?
No.
Yes.
Is he done? No square root of 2. So he is done. Right? Everybody good? Spectacular. Page 135 is your homework. 135 is your homework. Tomorrow we'll go over 136. You have a quiz. Wait. Whoa. You have a Swinkelhofer on polynomial, polymultiplication, and GCF. Only that tomorrow. So to remind you of what that is, things like this, x squared plus 3x plus 7 times x plus 2, be able to expand that, and be able to factor that. That's all that's on your quiz tomorrow. And it is 6 of these and 6 of these, I think.